So far with quadratic equations or quadratic functions, we've looked at how to graph them, and we've looked at how to find their minimums or their maximums. So now we're going to look at solving quadratic equations. So for our first two functions, the linear functions or linear equations, we know how to solve. So again, it's something like linear equation would be 6x minus 4 equals 10. Okay, you know how to solve that. Add 4, divide by 6. For exponential equations, we briefly looked on how to solve these. What we would do, we would graph in our calculator this side of the equation, graph this side of the equation, and then find the intersection point. For solving quadratic equations, there's numerous ways to do it. The first way I always look for when solving quadratic equations is to factor. Okay, so we're going to go into factoring here. This should be a review, but I'm still going to go over it. There will be some problems on your SAT that just have to do with factoring. Okay, so it says the zero product rule is AB equals 0 if and only if A equals 0 or B equals 0. Okay, that just means if you have two numbers, x times y equals 0, that one of them has to be 0 or the other has to be 0 for the product to be 0. Okay. So for example, if you have 2x equals 0, obviously 2 isn't 0, so that forces x to be 0. Okay, so this means that if we can factor a quadratic equation, then we can solve it by setting each factor to 0 in turn. This method only works when the right-hand side or left-hand, one of the sides of the equation is equal to 0. This is very important. This is something I see students forgetting all of the time. Okay, one side has to be 0 before you use a zero product rule. Okay, so for example, I'll see you guys factor, maybe it looks like this, and this equals 6, and you guys will say, okay, x minus 3 equals 6, or x plus 4 equals 6. That is not true. Okay, it's only true if it's equal 0. Okay, factoring, again, this should be a review, but we're still going to go over it. It says, given a quadratic equation, ax squared or quadratic, ax squared plus bx plus c, and a equals 1. When a equals 1, this is the easy case. You just have x squared. Find two numbers s and t such that two numbers multiply to c and add to b. So you're trying to find two numbers that multiply to the last number and add to the middle number. Okay, so example, it says factor the quadratics. So number 1 is x squared minus 13x plus 22. So we're finding two numbers that multiply to 22 and they add to negative 13. Okay, that would be negative 11 and negative 2. So negative 11 times negative 2 is 22. Negative 11 plus negative 2 is negative 13. So we would write it like this: x minus 11, since it's negative, times x minus 2, since it's negative. Okay, this is pretty simple, and it only works if this is x squared. Okay, so there can't be a number in front of the x squared. Okay, number 2, x squared minus x minus 56. So having a hard time focusing right now. Okay, so we're looking for two numbers that multiplies to negative 56 and adds to negative 1. I believe that would be negative 8 and positive 7. Okay, so negative 8 times 7 is negative 56. Negative 8 plus 7 is negative 1. Okay, so this may take some trial and error. You might have said minus 7 plus 8. Well, that would have added to plus 1. So you'll just have to check. So this would factor to x minus 8 times x plus 7. Number 3, x squared plus 17x plus 60. I'm just going to go ahead and give you the solutions. I want you guys to check these over though. So x plus 12 times x plus 5. Okay, 12 times 5 is 60, 12 plus 5 is 17. Number 4, x squared plus 2x minus 15. This should be, again, this is having a hard time focusing tonight. X plus 5 times x minus 3. So let's check that. So we have 5 times negative 3 is negative 15. 5 plus negative 3 is 2. Okay, number 5, let's look at this one. X squared minus 9. So we're looking for two numbers that multiply to negative 9 and they add to 0. Okay, so what would that be? Negative 3 and 3. So negative 3 times 3 is negative 9. Add to 0, yes. So this would be x minus 3 and x plus 3. Okay, number 6 is very similar. This would be x minus 5 times x plus 5. So minus 5 times 5 is negative 25. Minus 5 times plus 5 is 0. And then one more on the top of page 11. X squared minus 11x plus 30. That is x minus 5, x minus 6. We'll check that. Minus 5 times minus 6 is positive 30. Minus 5 plus minus 6 is minus 11. Okay, so that works. Okay, so this next set might not be a review. So this is the harder case where a doesn't equal 1. Okay, so for these examples, you're going to have a number in front, so like down here. So you'll have like 2x squared or 6x squared. Okay, so this makes it a lot harder. What we're going to do, we're still going to be looking for two numbers, s and t, such that they multiply to a times c. So before we just needed them to multiply to c. Now we want them to multiply to a times c. They still add to b. Okay, then we're going to rewrite the quadratic as. So we're going to copy the ax squared. We're going to write sx plus tx, and then we're going to copy the c. Then we're going to factor first two and last two terms separately. And then 4, we're going to factor the new quadratic. Okay, so those steps might seem a little confusing. I think it'll make more sense when we do some examples. So we're going to do 3 examples. Okay, so number 1 is 2x squared plus 7x plus 3. Okay, so we're looking for two numbers that multiply to a times c. Okay, well, a is 2, c is 3. So two numbers that multiply to 6 and add to b, which is 7. Okay, so that would be 6 and 1. Okay, so 6 times 1 is 6. 6 plus 1 is 7. Okay, so we've got 1 and 2 of those done. Now number 3, it says rewrite the quadratic as ax squared. So we're going to write 2x squared plus our first number x plus our second number x, which just would be x. So we're doing 6x and 1x, and then we copy c. Okay, you could have reversed this. You could have done 2x squared plus x plus 6x. Okay, it's still going to give you the same answer. Okay, and then it says factor the first two and last two terms separately. So we're going to factor these two terms, and we're going to factor these two terms. Okay, so factoring, it looks like we can take a 2x out of both of those. That would leave us with x plus 3. With this x plus 3, we really can't do anything with it, but let's go ahead and put it in parentheses, x plus 3. So we can't take anything out of those. Okay, now we have two terms here, and you notice the x plus 3 is common there. So we're going to take an x plus 3 out of the whole thing. Okay, with this term, we're left with 2x. With this term, we're just left with 1, okay, because you took an x plus 3 out of this. So there's our factoring, x plus 3 times 2x plus 1. Okay, before we move on, I want you guys to look at this step here. Okay, so when we rewrote this 2x squared plus 6x plus x plus 3, notice we didn't change this at all. Okay, so if you were to simplify this, this would be 2x squared plus 7x plus 3. Okay, so this step to this step didn't change at all. Okay, we just changed the way it looked, but it's still 2x squared plus 7x plus 3. Okay, and this is why that works. Okay, number 2, let's do another one. So we're multiplying to AC, which is 6 times negative 6. So multiply to negative 36 and add to positive 5. So I'm going to have to think about this one for a second. There's a lot of factors of 36. You have 1 and 36, 2 and 18, that doesn't work. 3 and 12 doesn't work. 4 and 9. 4 and 9 will work. So what? 9 and negative 4. So 9 times negative 4 is negative 36. 9 plus negative 4 is positive 5. Okay, so we rewrite. So 6x squared plus, let's do 9x. Okay, again, you can switch the order here. Minus 4x minus 6. Okay, factor 2 at a time. You could take 3x out of the first 2. That would give us 2x plus 3. Now you can take a negative 2 out of the second 2. That would give us 2x plus 3. Okay, and it should always end up like this if it factors. So we can take a 2x plus 3 out of both. We're left first term, 3x, second term, minus 2. Okay, and we have one more, which I'm going to use a different piece of paper just because there's not enough room. So number 3 is 10x squared minus 29x minus 3. Okay, so we want to find two numbers that multiply to a times c. So 10 times negative 3, so negative 30. And then we want them to add to negative 29. Okay, that one's pretty simple. Negative 30 and positive 1. Okay, so we want to rewrite 10x squared minus 30x, again you can switch, plus x minus 3. Okay, factor first 2 and last 2. Looks like we could take a 10x out of the first 2. That would give us x minus 3. Okay, the second 2 we can't do anything with, but let's go ahead and put it in parentheses so it's easier to see. Now you can see we're going to take an x minus 3 out. Just let me move this. X minus 3, we're left with 10x plus 1. So there's our factoring. Okay, the nice thing is with factoring too, you can always check. Okay, so you can go ahead and redistribute. So x times 10x, x times 1. Negative 3 times 10x, negative 3 times 1. You can always check your answer with factoring, which is nice. Okay, so that ends page 11. We're going to move on to page 12. Okay, so page 12, we're actually going to start solving. We're going to
Okay, so this is solve each equation for x. So number 1, I don't know why this is having a hard time focusing. There. Okay, number 1, we have x squared. It's like it's focusing and then it sorry, it's probably making you guys dizzy. Okay, x squared plus 5x equals 24. Okay, before we can even try to factor, okay, one side has to be 0, okay, which is clearly not. Okay, so once again, I see a lot of students factoring this x squared plus 5x and then setting each term equal to 24. That is not correct. That is wrong. Okay, so we have to have one side equal to 0. So we're going to subtract 24 on both sides. Okay? So x squared plus 5x minus 24 equals 0. Okay, so we're looking for two numbers that multiply to negative 24 and add to 5. So I'll have to think about this one. Negative 3 and positive 8. So x minus 3 times x plus 8 equals 0. Okay, so now since one side is equal to 0, we can set each one equal to 0. So x minus 3 equals 0, x plus 8 equals 0. That's by the zero product rule. So that gives us x equals 3 and x equals minus 8. Okay, notice when we're solving these quadratic equations, we have two solutions. Okay, and that's because of this x squared here. So if it was x cubed, which we actually won't look at solving those, you would have 3 solutions. If it was x to the 4th, you'd have 4 solutions. Okay, so for quadratic equations, you will have 2 solutions. Okay, number 2, we have x squared equals x plus 6. Okay, first thing we have to do is get one side equal to 0. So I'm going to go ahead and just subtract x and 6. You could have brought the negative x squared over. That makes it a little more complicated because then you'd have a negative on this side. Okay, so we're looking for two numbers that multiply to -6, add to -1. That would be -3 and 2. Let's check that. -3 times 2 is -6. Yes, that works. Okay, so now we can set each one equal to 0. So we'll have x equals 3 and x equals -2. So again, two solutions. Okay, and then the last one we have 2x squared plus 5x plus 3 equals 0. Okay, so this one's the harder case. So we're looking for two numbers, multiplies to 2 times 3, which is 6, and then adds to 5. So what is that? 2 and 3. 2 and 3. Okay, so rewrite 2x squared plus 2x plus 3x plus 3 equals 0. Okay, so I did 2x squared plus 2x plus 3x, and then you copy the plus 3, or the constant, and then we have equals 0 here. Okay, notice again we didn't change this equation at all. It's still 2x squared plus 5x plus 3. Okay, so factor two terms at a time. So we can take 2x here. That would give us x plus 1. We could take a 3 out of each of these. That would give us x plus 1. So that works. We still have equals 0. Okay, take an x plus 1 out of both. So 2x plus 3 equals 0. Okay, so we have x plus 1 equals 0, and 2x plus 3 equals 0. So this would be x equals -1. Here we have a little bit more work to do. So 2x equals -3, x equals -3/2. Okay, so again, the main thing with quadratic equations, this is very important, one side has to be equal to 0. So do not forget that one side has to be equal to 0. We're just going to do a quick graphing example for factored equations. So it says, example, the graph of a quadratic function is shown below. Find an equation that represents the function f. Okay, so let's say we're given this picture. Okay, so we have a point at 1, 0, 1, 2, 3, 4, 0, and also 0, 2. Okay, and then our parabola looks like this. Okay, so what's important here are these 2 points. Okay, we can do something with that. So what we've done with given quadratic graphs so far is we've normally been given the vertex, okay, which we clearly don't know, okay? But we do have these 2 points. So those are the zeros of our function, or the zeros of our graph, okay, which is actually what the factors will be, okay? So we have that x equals 1, and we have that x equals 4, okay? When you have that, when you have x equals 1, the function is 0. When you have x equals 4, the function is 0. Okay, so you have the points 1, 0, and 4, 0. So when you input 1, output 0. Input 4, output 0. Okay, so that means we can write x minus 1 equals 0, x minus 4 equals 0. So our function is going to look something like this. There's going to be some factor out front. Remember, we always have this a. And then it's going to be the x minus 1 times the x minus 4. Okay, so our function is going to look something like that. We know it factors like this because of those 2 zeros. Okay, so this is what a factor looks like in graphing, which we're going to look at this more when we go into polynomial functions. So we're going to factor polynomials, and then we're going to draw all of the zeros. Okay, so quadratic, this quadratic function has 2 zeros, and the factor looks like that. Okay, so now all we need to do is solve for this a, and we're going to do that with our other point. So I'm just going to put the point 0, 2 that we have. That means when you input 0, the output is 2. So output 2 equals a times 0 minus 1 times 0 minus 4. So that's here. Then we have 2 equals, that's minus 1 times minus 4. So positive 4. So then A is 1/2. Divide by 4 on both sides, yeah. So then our function, which I'll write down here, is 1/2 x minus 1 times x minus 4. Okay, and then we could go ahead and distribute out and have it in general form. Okay, but that's fine the way it is. Okay, so when you have factors like that, that gives you the zeros of the function. Okay, and then we have one more thing to learn for solving quadratic equations, and that is the quadratic formula. Okay, so when you have a quadratic equation, first thing you have to do is one side needs to be equal to 0. Okay, that's the first thing you do with quadratic equations. Then you try to factor. Okay, that's just because it's easier. If you hate factoring, you can always use the quadratic formula. Okay, if you can't factor it, then you use the quadratic formula, which the quadratic formula says the solutions of the quadratic equation ax squared plus bx plus c equals 0, where a doesn't equal 0, are negative b plus or minus the square root of b squared minus 4ac divided by 2a. This has to be memorized. Okay, there will be a couple questions on your SAT where you'll need to use this, or it'll be helpful to know. Okay, I have, again, once again, make sure the right-hand side of the equation is 0. Okay, first example, it says solve each equation for x using the quadratic formula, which we're going to try to factor each first. Make sure solutions are in simplified radical form. Okay, that just means since we're going to have this square root here, we're going to make that as simple as possible. Okay, so number 1, it's x squared plus 5x equals 24. So first of all, one side of the equation needs to be equal to 0, so we're going to subtract 24 on both sides. Okay, try to factor first. This does factor, I believe. We had one that was just like that. 8 and 3, negative 8, negative 3. Or negative 8, no, I'm sorry, positive 8, negative 3, yeah. Positive 8, negative 3. So I'm going to go ahead and do this, and then we're going to check it with the quadratic formula. So x plus 8, x minus 3 equals 0. This gives you x equals minus 8, x equals 3, which you can check that. Okay, but let's go ahead and check it using the quadratic formula. So we have that our solution is x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. Okay, which I'm going to put another thing here. A here is 1. I'm looking at this. B is 5. C is negative 24. So I'm looking at this. Okay, so all we have to do is fill this in. So this would be negative 5 plus or minus the square root of 5 squared, that's b squared, minus 4 times, oops, sorry, you can't see that, 4 times a times c, which is negative 24, divided by 2 times 1. Okay, equals, so I'm just simplifying now, negative 5 plus or minus 5 squared is 25, negative 4 times 1 times negative 24, which I can't do that in my head. Positive 96 all over 2. That gives you negative 5 plus or minus the square root of 121 over 2. Okay, we want to simplify the square root here. Okay, so this is negative 5 plus or minus the square root of 121, which is actually 11, divided by 2. Okay, so that gives us x equals negative 5 plus 11 divided by 2. So negative 5 plus 11 would be 6 divided by 2, which is 3. And then we want negative 5 minus 11, which would be minus 16, divided by 2 gives you minus 8, which hopefully that's what we had, and it was. Okay, so obviously factoring is much simpler. If you hate factoring, this will work every time. Okay, factoring won't work every time. Okay, so this is consistent. Quadratic formula will always work. It just takes a little bit more time.
I like to just check to see if it factors first. Number 2, x squared plus 2x plus 2 equals 0. One side is already equal to 0, so we can go ahead and start solving. Let's see if it is you can factor it. So multiplies to 2, adds to 2, nothing. Okay, so we have to use the quadratic formula here. A is 1, B is 2, C is 2. Alright, so we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 divided by 2 times 1. So this is negative 2 plus or minus, let me put a thing here. Negative 2 plus or minus the square root of 4 minus 8 all over 2. Negative 2 plus or minus the square root of negative 4 divided by 2. Okay, so we have a problem here. Okay, this is negative 4. Okay, if you put that in your calculator, that's going to give you no solution. Right now, we haven't studied imaginary numbers, so we're just going to put no solution for here. I think it's one of the very last topics we'll do is imaginary numbers. Okay, and we'll look at that. But right now, we're just going to say it has no real solutions. No real solution here because of the negative 4 there. Okay, one more. We have 3x squared minus 4x minus 5 equals 0. Okay, again, this first side is already equal to 0, so we don't have to move around or anything. We'll see if we can factor. We would want two numbers that multiply to negative 15, add to negative 4. Okay, 15 is 1 and 15, and 3 and 5, so that will not factor. Okay, so we're going to have to use the quadratic formula, which I'm trying to get this to focus. Okay, so we have A is 3, B is negative 4, C is negative 5. So we'll have x equals negative b. Here's negative b here. Okay, so negative of negative 4 would be positive 4. Plus or minus the square root of negative 4 squared minus 4 times 3 times negative 5 divided by 2 times 3. Okay, so simplifying, I'm coming up here. Should have left more room. X equals 4 plus or minus the square root. Be careful with this negative 4 squared. Okay, this is a really common mistake. I'll see you guys do negative 4 squared in your calculator. Okay, that gives you negative 16. What you're telling the calculator to do, because the calculator does order of operations, you're doing, okay, 4 square 4, and then take the negative, because the calculator uses order of operations. So they do exponents first and then subtraction, which is the negative. Okay, so your calculator did 4 squared and then the negative. Okay, what you really need is negative 4 squared, okay, which is negative 4 times negative 4, which is 16. So be really careful with that. You should never have a negative here. Okay, so we'll do 16, then negative 4 times 3 times negative 5. That should be 60. So plus 60 here, divided by 6. Okay, so simplifying again, it's the square root of 76 over 6. Okay, this will go ahead and give you, you can go ahead and do your approximate answers here. So if you wanted approximate answers, you would do square root of 76. You could do plus 4 first and then divide it by 6. There's one approximate answer. Then you would do 4 minus the square root of 76 divided by 6. So you have this 2.12 is your approximate, and then negative 7.79. Now, most likely on the exam, they're not going to give you approximate versions. They're going to want the exact versions. Okay, which is this. Okay, but we can simplify this. Okay, so underneath the square root, we're looking for a perfect square that goes into 76. Okay, so we're looking for a perfect square. What are perfect squares? You have 2 times 2, which is 4. 3 times 3, which is 9. 4 times 4 is 16. 25, 36, 49. What's the next one? That was 7. 64. Okay, those are perfect squares. You're looking for perfect squares that go into 76 here.
Okay, let's start with larger. So 36 will not go into it. 49, I could have checked that first. 49 doesn't, 36 doesn't, 25 does not. Does 16, let me check that. 76 divided by 16, no. Does 9, no. And I believe 4 does. Yes, 4 does. Okay, so we're going to rewrite this as 4 plus or minus the square root. 76 is the same as 4 times 19 divided by 6. Okay, so x equals, this is starting to get messy, 4 plus or minus the square root. Okay, now we know what the square root of 4 is, which let me go ahead and separate this because we can do one more. Times the square root of 19 divided by 6. Okay, so I just separated this out. That's the same as 4 plus or minus the square root of 4 is 2 times square root of 19 divided by 6. Okay, I'm going to come over here now just because I'm running out of room. So we have x equals 4 plus or minus 2 square roots of 19 divided by 6. Okay, we can factor out a 2 here. So 2, this would be 4 plus, 2. Plus or minus square root of 19 divided by 6. Okay, do you see what I did there? I factored out a 2 of these two terms. So this is 2 times 2 plus or minus square root of 19. I took a 2 out of these two. And then now you can see that this turns to 3. So this would be 2 plus or minus the square root of 19 over 3. Okay, so this is the solution that most likely the SAT is going to give you. The good thing though is you can go, because most of these are multiple choice, you can go through each of your solutions and see which one matches. Okay, so we got that the solutions were like 2.1 something. Okay, you would do this 2 plus the square root of 19 divided by 3, and you're going to get the 2.12. Okay, so you can always go to your multiple choice solution, see what those are approximately, and then check with your approximate solutions. So that's the good thing about multiple choice. You don't have to do this. Okay, so just check their solutions with your solutions and they should match up. Okay, so go ahead and we're going to stop there. You can do practice set 3 now. This one is exponential and quadratic functions and equations. Okay, so go ahead and do practice set 3 and then check your solutions and then let me know if you can't get a solution or if you need help with any of those.